In this first video, we're going to talk about how to graph a parametric function and what exactly a parametric function is and what it represents. If you will take a minute, pause the video, and copy down everything on this screen, this explains the difference between rectangular coordinates and parametric functions. A rectangular function has one equation and uses two variables, and usually an x and a y. The x represents the horizontal distance, the y represents the vertical distance. Parametric functions introduces a third variable, uses two equations and three variables that produces one graph. So t is usually the third variable, usually represents time, and it's called the parameter because that variable is used in both equations. The x still represents horizontal distance and y still represents the vertical distance. Now, why do we use parametrics rather than rectangular? Rectangular equations will only tell you the location of an object. It will tell you where it is, where it's been, but it doesn't tell you anything about when it got there. A parametric equation will tell you the location of the object, but it also tells you the time it arrived at that location and which direction the object is moving. So movement and time are why we need to use parametric equations. Okay, first thing we're going to look at is just simply how to graph with that third variable. So if you will look at these equations, if you have the parametric functions worksheet, these are problems on the worksheet, so you can graph as we go. If I want to graph, notice my t-chart now has three columns, a t, an x, and a y. The t values, since we're talking about time, will usually start at 0, because negative numbers don't really make sense for us at time. If you're running a race, the time starts at 0. So we want to know what happens from the beginning point of 0. To get our values, we are simply going to plug the 0 into the t value for both equations. So for the first one, we would do 1 plus 2 times 0, which is 1. To get the y, we'll plug 0 into the y, so 2 plus 3 times 0, which is 2. So I'm going to graph the point 1, 2. Okay, this is my starting point, and I'm not going to go past that point on one side. So I have to see where the next t value takes me. So now I'm going to plug in 1. So 1 plus 2 times 1 is going to be 3. Plug in for the y equation, so 2 plus 3 times 1 is 5. So my next point is 3, 5. And you can see that I am moving up and to the right. Okay, so if I keep plugging in those numbers, when I plug in 2, I get 5 and 8. So let's graph 5 and 8. And then when I plug in 3, I'm going to get 7 and 11. Okay, so remember my starting point was the 1, 2. I'm moving up and to the right, so I only put an arrow on the right side that's pointing up because my graph keeps going that direction, but I don't go past the starting point. Okay, now, if you want, pause the video for a second and see if you can do part B, and then you can start it up and see if your answer is correct. So again, we're just going to plug these numbers in. When I plug in a 1, I'm going to come out with 3 and 5. When I plug in 2 for the t's, I'm going to get 1, 2. When I plug in 3, I'm going to get negative 1 and negative 1. Okay, so I graph the points in order, starting with when t is 0. Okay, 5, 8 is my starting point. Then I go to 3, 5, 1, 2, and negative 1, negative 1. So this time I am moving down and to the left. Okay. Now, look at the characteristics they have in common. How are those graphs different? How are they alike? Well, they do have some of the same points, but they start in different places, and they're going in different directions. So you'll notice these graphs are not exactly the same, even though they share some points, because of the starting point and the direction that it's moving. Okay, if you will pause the video, work number 3 and 4, and then you can start the video when you have done as much as you can do. Okay, so look at these answers for number 3 and 4. And notice in this case, both graphs start in the same place, they go the same direction, but one is moving faster than the other. Your t=1 values are not the same. So one of the equations has moved faster than the other one. Okay, now again, try number 10. See if you can sketch this graph, fill in your table, pause the video until you have finished, and then you can check your answer on the next screen. Okay, so here is what your answer for number 10 should have looked like. Okay, and you will notice that this one did not come out linear, and that is because our x equation had a t squared in there. So that's what's making it come out to look like a parabola. You still need to mark the starting point and the direction that it's moving. So when you're graphing parametrics without the calculator, you're simply plugging in numbers to find your x and y values and plotting your points.